Today we are going to compare fractions and mixed numbers. Our goal is to compare and order mixed numbers. So in previous tutorials you learned about finding the lowest common denominator, least common multiple, as well as comparing fractions. So now we're going to take it a step further and compare fractions and mixed numbers. For your vocabulary, we have several different terms that it's really important that you know. A mixed number has a whole number part and a fraction part. For example, 1½ is a mixed number. A proper fraction is a fraction whose numerator is less than its denominator. An example of that would be 3/4. An improper fraction is a fraction whose numerator is greater than its denominator. An example of that would be 9/4. So make sure you take a minute to pause if you need time to copy down your vocabulary. So the first thing that we need to make sure you understand is writing mixed numbers as improper fractions. To write a mixed number as an improper fraction, multiply the whole number part and the denominator. Then you add the numerator and write the sum over the denominator. So what does that look like with numbers? Well, if you have a number like 2 and 5, 6, you multiply then add. So it would look like 6 times 2 plus 5 all over 6, which would give you 6 times 2 is 12, 12 plus 5 is 17 over the denominator, which is still 6. So the really important thing to take away from this is that the denominator doesn't change. And of course we multiply the denominator and the whole number and add the numerator. Writing improper fractions as mixed numbers. To write an improper fraction as a mixed number, you divide the numerator and the denominator and write any remainder as a fraction. So many of you are used to writing it as a decimal. You need to write it as a fraction in this case. So in order to do that, it's really a good idea to just think of fractions as division problems because that's really what they are. 17/5 is just 17 divided by 5. So you have 17 divided by 5. And if you want to write it 17 divided by 5, that's perfectly fine. Both mean the same thing. So when you divide 17 by 5, you get 3 remainder 2. Well, this is an elementary school, so we don't write remainder 2. We write 3 as our whole number, and our fraction is 2 over the denominator, which is 5. So it gives us 3 2/5. So we can see that those are inverse operations, writing mixed numbers to improper fractions and writing improper fractions as mixed numbers are both inverse operations. Now I want you to take a minute to look at what your notes should look like this far. So we've had a lot of vocabulary, we've had a couple examples, but a lot of words that we've been writing in our notes at this point. So take a minute and pause and compare your notes to my own just to make sure you have all the information you need. Now let's look at an example of a word problem. County fair. The county fair holds a pie eating contest. Participants are to eat as many pies as they can in 10 minutes. Julissa ate 4 1/4 pies. Michelle ate 5 pies. Daniel ate 22/5 pies. And James ate 4 1/2 pies. Order the amounts of pies the contestants ate from least to greatest. Who ate the most pies, it should say. Fixed for you. So let's first start with 4 1/4. So we have Julissa. So Julissa ate 4 1/4. So first I'm going to change this into an improper fractions. And yes, you can change it to a decimal first. But in this case, because we've been working on least common multiple, we're going to continue with that and use the lowest common denominator, or the least common denominator. So in order to turn it into an improper fraction, we of course need to multiply 4 times 4 plus 1. So 4 times 4 is 16, 16 plus 1 is 17, and we keep our denominator the same. 5, of course, is 5 over 1. 22/5 stays the same. And 4 1/2, 4 times 2 is 8, plus 1 is 9, is 9/2. So now we have our improper fraction. So we can tell who ate the most pies probably already. If you just look at the whole number of 5, we know that's bigger than 4. So we know that that's greater. And if you look at 22 over 5, you can ask yourself, how many groups of 5 are in 22? Well, there's 4 with a remainder. So we know that this person only ate 4 pies. So if it didn't tell us to order the amounts, this is one of those math problems where we could solve it without doing much math. So we already know that Michelle ate the most. But now we have to take it a step further and order it from least to greatest. So between our denominators, 5, 2, and 4, we need to ask ourselves, what's the lowest common denominator? Well, I know if it ends in a 5 or a 0, it's a multiple of 5. And 2, of course, and 4 are going to have the same patterns because they're both even. So we really have to look at 4 and 5. So 4 and 5, my lowest common denominator is 20. So it's going to be over 20. So then I just have to ask myself, how do I get from each of these numbers to 20? Well, I know that 4 times 5 is 20, so I have to multiply 17 times 5. I know that 1 times 20 is 20, so I have to multiply 5 times 20 in my second example. In my next one, again, because 4 times 5 is 20, 5 times 4 is 20, so I multiply my numerator and denominator by 4. And finally, 2 times 10 is 20, so I multiply 9 times 10. So then I can just multiply each of my numbers. 5 times 10 is 50. 5 times 7 is 35. 50 plus 35 is 85. If you wanted to, you could solve this by working up and down, but I want to model using the distributive property to help you. 5 times 20 is 100. 22 times 4 is 88. And 9 times 10 is 90. So now I can order the pies from least to greatest. So I can see my smallest amount, let me do that in a different color, is here at 85. My next is 88. 90 is my third, and 5 is my fourth. So that gives me 4 1/4, 22 fifths, 4 1/2, and 5 are my pies from least to greatest. So make sure you have all your notes copied down. Make sure you're following along with me, and make sure that you are asking any questions in your notes. Let's look at another example where we compare the fractions with area models. And these are the types that normally you actually wouldn't necessarily use area models to compare the fractions, but I want to show you why these problems really work. So looking at area models at 3 1/2, we can first say, okay, well we have 3 wholes and 1/2, and you can see I've put identical rectangles together to represent those area models. And to the best of my ability, I will break them up into halves and, in this second case, fifths. So starting with 3 1/2, that gives us 3 wholes. So we can shade in 1, 2, 3. and 1/2. So that's our first area model. Now 18/5 is a little different. 18/5 we're going to want to break it up into fifths. So each whole we're going to represent fifths. So of course 2/2 is 1 whole, I can see in each of these cases. And now 18/5 I need to break it down as neat as I can into fifths. So of course we have 5/5 is 1 whole. So now I have each one broken down into fifths, and I can of course color in 18 of them. So again I have 5, I have 10, I have 15, 16, 17, and 18. And when I can compare these fractions, it can really help me out. So another way to do this to find the lowest common denominator between, of course, so this helps us turn it into, first of all, an improper fraction, because I have 2, 4, 6, 7 halves is the same as 3 and 1/2. And 18/5, of course, is already an improper fraction. So I can actually divide these once again to find equal quantities. So if I cut this into fifths, so I have 1, 2, 3, 4, and 5. Now I can see that on the other side I can cut it in half, and I can now measure my shapes. So I have a common denominator. So I can see in each case, each one has 10. So 10 tenths here and 10 tenths here. So now I can of course count 10, 20, 30, 1, 2, 3, 4, 5. So 7/2 is equivalent to 35 tenths. And then 18/5, again, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36 is 36 tenths. And again, I just wanted to show you another way of looking at it and to show you why it works. It's really important in math that you can actually show why something works so that you have a deeper, better understanding of your mathematical equations. So great job today. Go ahead and pause this for a minute. Rewatch it if you need to copy down those area models. Now I want you to look ahead at your notes. The last page of notes you can see are similar to mine. I've drawn pretty small area models in my notes. And we have the county fair problem as well as the area models. Go ahead and take a minute to pause to check your notes. Make sure you have all the important information. Another fantastic job with your notes and your lessons. Make sure you're paying attention and rewinding if you need extra help. I've hoped you've enjoyed your tutorial, and I hope that it's answered any questions. Remember to include any questions and summaries in your notes for next time. Great job again.